Okay, so we had discussed about the tools that we are going to use for this entire CI/CD pipeline. Now it's time to discuss about complete architecture of CI/CD pipeline. So I brought a large diagram of infrastructure which has written in a PDF file, and I'll attach this PDF file into the GitHub so you can go through it. So this is the complete CI/CD pipeline and stages and jobs, and I will be explaining you from the beginning what exactly happens in complete DevOps principles. So stay tuned. So here we have three people. I can say that three teams. So developers team and DevOps team and testing team. Let me zoom in a little bit. You guys can see perfectly. So what these guys do, they do push their source code into any source code management. It can be GitLab, it can be GitHub, it can be Azure repos, it can be AWS code commit, whatever it may be. So our requirement, being a DevOps engineer or operation engineer or DevSecOps engineer or MLOps engineer, that we would like to create a CI/CD pipeline from that source code management. So that's what, for this demo, for this entire explanation, I am going to use GitLab as a source code management and GitLab for the entire CI/CD pipeline. So if I step into the CI/CD pipeline jobs and stages, so I'll show you in this session itself, how we can write the pipeline as a code, which we call as a we write in YAML syntax pipeline as a code, and the file extension is dot gitlab -c.yaml file. So in that, we are going to add stages, and in that stages we are going to use those stages for jobs. So if I take a look into that, imagine in the organization you may work on compile language, you may work on interpreter language. So based on the languages or based on the stacks, you can either have the maybe one or two jobs more, or you can have a lesser two or more jobs in your architecture diagram. But the principle, the flow is same for all the CI/CD pipeline. Here at the first stage, I have added in this architectural diagram called as an install. So if you are using any compile language, so it's your responsibility to install all the dependencies of this stack. It can be Java, it can be .NET, or it can be React, or it can be Python on your target runner. So you might have added a target runner to your GitLab. So you need to install all the dependencies like supported versions of your stack and other dependencies. So this is the first stage called as install. So what this stage will do, under the stage we have one job called as install dependencies. So it will enable all the dependency installation on the runners to execute your next stage. So the next stage we have the stage called as a build. If it is a compile language like a Java, you may use a project management tool as a Maven. So with that you can compile your source code. You can create the artifact like jar var ER extensions. If it is interpreted language, so you can directly go to the stage testing after initializing your dependencies. So we have discussed successfully about the install stage and the build stage that we have seen two jobs. The under the install stage we have the install dependencies, and the build stage we have the compile code job. And the next stage into our CI/CD pipeline called as a stage test. So under this stage we have the few jobs. The first job is unit test. So what is happening, this job will go and test all your test cases into your source code which was written by your developer, and for that we need to add one stage, one job for this. So this is called as unit test. And the second job in the stage test called as scanning your code quality and code coverage. For that we are going to use a SonarQube. So we can integrate the SonarQube into your Sonar Scanner CLI into your runner. So the Sonar Scanner CLI will go and scan your source code, and will give a code quality and code coverage. I mean, it will scan your code vulnerabilities. So that's the another job under stage test. And the next job we have the Semgrep. So Semgrep is a tool of CLI which will scan all your source code, and it will give you the first party vulnerabilities, which means whatever code you have written, it will scan your source code, and it will give a result of how many vulnerabilities are there, the code that you have written and you kept in your source code management called as a GitLab. And the next job under the stage called as a third-party vulnerability scanning, we called as a security or software composition analysis. For that, we are going to use a Trivy. So Trivy is a tool that it will go and scan all your source code and for finding the third-party vulnerabilities such as dependencies of open source modules, libraries, and all the open source related stuff. And the next job under the same stage called as a malware scan. So this can, we are going to use a ClamAV. So ClamAV is a tool that it will go and it will scan you all the files for viruses, malwares, and trojans into your in a source code. So that's what, under the stage we have these many scanners that we won't let any vulnerability, any security flaws are going for into the deployment. And the next, if you are using a container based deployment, so we are going to have the Docker build and scan. If you are using a container package based deployment, so we may need to package your source code. So for that, we have already written the Docker file and we kept regularly into the source code management. So here, we are going to use a Docker file to create the Docker image. For that, we are going to create a new separate job to build a Docker image. We call it as a Docker build or Docker image build. So this stage will create the Docker image out of the Docker file, and the next job inside of same stage called as a Docker image scan. So this is going to use a Trivy as a tool. It will scan your entire image with your with the tool that you have installed called as a Trivy, and it will give you all the reports of your Docker image vulnerability. So that's how you can prevent all the security issues even on your Docker image. So once the Docker image build and Docker image scan gets some completed, so we are going to push the Docker image into the image registry that we called as a Docker hub. So this is where we have the another stage for pushing your image into a Docker image registry. So for that, we have the job under this image push registry. The job name called as a Docker image push to Docker hub. And the next, once it got pushed, so here, we have the next stage called as a deploy. So we are going to deploy this image as a container instead of a Kubernetes cluster. And for that, we have the dedicated Kubernetes cluster. And on that Kubernetes cluster, we have installed one tool called as Argo CD. So what this tool will do, it will pull the image from your image registry, and it will pull the all the manifest file that you have kept into our source code management. So it will pull both, and it will get sync and it will get deployed into your Kubernetes cluster. So this is how you can get to know that, the deployment has succeeded. And this is the Argo CD, is a continuous deployment and delivery tool that you can use it for CLI, and you can connect this tool into your GitLab runner, into your Kubernetes cluster. So you can pull all the manifest file from your source code management, and you can get applied into your Kubernetes cluster. And you can use rolling updates, rollbacks, and you can use canary deployments, so whatnot. You can use a number of deployment strategies with Argo CD. So once the deployment has succeeded into Kubernetes cluster, so we are going to check the health checks, whatever service that we have exposed. It can be node port or it can be load balancer. So we are going to take that URL or IP address. So we are going to add that as a separate stage for checking the health checks of that particular IP address. So in that, we have the job name called as a check deploy health. So this job regularly will go and it will hit the URL, and it will find the HTTP response. It can be 200 okay, or 300 reduction, or 400 or 500 client or server side error. So accordingly, it will let the pipeline go for next stage. So the reason why we have integrated this health check, because we would like to know how our pipeline check and how the deployment has happened, whether it is succeeded deployment or failure deployment. We would like to know via CI/CD pipeline. So once it is succeeded, at the end, we have the scanner called as a DAST. In a short, in that stage, we call as a DAST scanner. So the full form of DAST scan is called as a dynamic application security testing. So with this scan, what we are going to do, we are going to scan our application which is live in a respected environment. It can be non-prod or testing or production. So we are going to find, is there any vulnerabilities are present in a running application. So that's why we are going to use OWS AP JAP as a data scan, and we will scan the entire our application with that OWS AP JAP, and we'll find the report, how many possible vulnerabilities are there. It can be medium, it can be higher, it can be low. So all those things we are going to get into the data scan. So this is typical CI/CD pipeline architectural diagram, for any organization. If you take any organization, so it can be a similar, you are going to build your application, you're going to test it, you're going to create a Docker image, and you're going to deploy it into, it can be a Kubernetes deployment, or it can be a single server deployment, and later you're going to enable the data scanning and all, so this is the best way you can integrate. This is how you can integrate DevOps and DevSecOps in between it, security is everywhere. And you can make sure that your entire application is stay away from vulnerabilities by following these all the stages and the jobs. So these are all the stages and jobs that you are going to run in GitLab. You can use any you can use Azure DevOps, you can use a GitHub Action. So CSD tool can be different, but the entire pipeline flow is similar for all the CSD tool. So I hope it is make you sense and understand about the entire architectural diagram of a CSD. So let's jump into the practical implementation of this architectural diagram. You can see more detail about it. And if you still have any questions about it, so I request that you drop your comments in comment section.